Okay, so today we're going to be solving quadratics with the square root property. So the directions here in the notes say that we're going to be using 3 different methods over the next few school days. This is the first method that we're going to show you. And then the next 2 sets of notes will also have methods for solving quadratics. And we're going to focus solely today on the square root property. So this method is used when the quadratic has no linear term or if the quadratic is in vertex form. So you can see in the standard form on the left that we have no linear term here. And then we've got our vertex form. So both of these are forms in which we would use the square root property. So what are the steps? You want to isolate the squared term or the parentheses squared if it's in vertex form. Then you'll take the square root of both sides to get rid of that power of 2. And then we've got to remember to find our 2 solutions. So we're just going to jump right in here on example number 1. And our first step is that we've got to isolate the squared term. So that means that we're going to add 6 to both sides. So we'll have, and of course that jumped on me, I'll go back down. We're going to have 8x squared is 32. So we're not isolated yet. We need to divide both sides by 8. So x squared is 4. Now we take the square root of both sides. This is a step I think you might forget. When you're taking the square root, you have plus or minus 2. Because this is saying x squared is 4, meaning all the numbers that be squared are 4. The negative 2 times negative 2 will give you a 4. Right? And then the last step there is to put that in a solution set. Okay, looking at number 2, I don't have anything to add or subtract to move away from the squared term. I just have to divide by negative 5 to isolate it. So m squared is a 64. And then we're going to take the square root of both sides. And m is plus or minus 8. And then we put that in a solution set. So both example 1 and example 2 were both perfect squares. It's not going to happen on numbers 3 and 4. So let's move on to those 2. So on number 3, we're going to subtract 2 to isolate our squared term. And then when we take the square root of both sides here, this is going to look a little bit like the previous night's notes and homework on breaking down square roots. The biggest square root factor of 32 is 16. So b is going to be plus or minus 4 root 2. Put that into solution set. Okay. Number 4, add 5 to both sides. And we're going to divide both sides by 2. And then when we take the square root of both sides, we have a small problem because we cannot take the square root of a negative number. So this would be no real solution. Or we can write it like this. Okay, let's move to number 5. So number 5 is the first one we have that's like in this vertex form. And our squared is already isolated. We're going to the square root of both sides. So this is x minus 3. Don't forget. Plus or minus 5. Now when you add 3 to both sides, remember that 3 is going in front of plus minus 5. Don't leave your answer like this. Okay, you've got 2 answers here. You've got 3 plus 5, which is giving you 8. And then you have 3 minus 5, which is giving you negative 2. So then the answers are negative 2 and 8. Okay, so I'd like you to try that exact same thing on number 6. Pause the video and do not unpause it until you've worked on number 6. Okay, so here's the answer to number 6. Number 7 is going to be pretty similar to that, only we just don't have our squared term isolated yet. So we're going to need to move that negative 3 in order to be able to take the square root of both sides. So when we add 3 to both sides, we've got 9 equals c minus 2 squared. Now we take the square root of both sides. We've got plus or minus 3 is c minus 2. Add 2 to both sides. So 2 plus or minus 3 is c. So my answers, we've got 2 minus 3, which is a negative 1, and then 2 plus 3, which is a 5. All right, let's move over to number 8. We want to isolate this negative 5x squared, so we're going to add 4 to both sides. And then we're going to divide both sides by negative 5. And then take the square root of both sides. X equals plus or minus the square root of 10. And then if it was possible for us to break this down with any perfect square factors, we would. But the only factors of 10 that we have are 1 and 10 and 2 and 5. And we aren't getting any perfect squares there. So we're going to leave this alone in this form, because this is as simplified as it could get, and put it in solution set. Okay, moving on to number 9. Number 9. We've got quite a few steps here that we need to do in order to isolate the z plus 3 squared. So let's get to it. Subtract 6 from both sides. We're going to have a 44. And then we're going to divide both sides by 4. And then square root of both sides. Don't forget your plus or minus. And then this can't be broken down. There's no perfect square factors of 11, so we're going to leave that alone. And we're going to subtract 3 from both sides. So we have a negative 3 plus or minus the square root of 11. And then we're going to put that in a solution set. I'm going to actually have you guys try number 12. Because number 12 is pretty similar to number 9. So pause the video, try number 12, and then unpause it to check the answer when you're done. Okay, here's the answer to number 12. And I included each step there so that you could see how I got from negative 6 divided by negative 2 to be a 3. And then I color-coded as I moved each step. So I hope that's okay. We're going to move up to number 10 next. So number 10, we're going to isolate this 3x squared. So we're going to add 28 to both sides. So we've got 3x squared equals 60. Now we're going to divide both sides by 3. So x squared is 20. And then we take the square root of each side. And then I know factors of 20, 2 and 10, and we've got 4 and 5, that I got a perfect square factor of 4. So square root of 4 and square root of 5 means this is going to end up being plus or minus, because I took a square root of both sides, 2 root 5. And then we end by putting that in a solution set. Okay, that leaves just one problem left. Number 11. It's got a fraction, your favorite. Let's isolate this one. I'm going to add 56 to both sides. And we've got 2/5 w squared. Now to get rid of this fraction, what I'm going to do is multiply by the reciprocal. So that'll cancel these out and leave me with w squared. And then we've got divided by 2 is 25. So that works out nicely. So that when we take square root, it's a perfect square. My answer is plus or minus 5. All right, so I hope that makes it clear for you how to solve a quadratic equation using the square root property. Okay, have a great day.